Right, okay, we're going to start by looking at the Unpaired T-Test. There is a full worked example in here. If you click on the workbooks at the bottom, it'll take you through it, but we're going to do the data ourselves and have a look at this. There's also some sample data there, and a sample data worked out, which you won't have a look at until you've had to go at the sample data yourself, of course. Now, so go back to the raw data. What's our situation here? It says this is data about body weights of a small group of men and women. The data's been in a particular way here, but alternatives might be better. So we'll have a look at a couple of ways of looking at how we could do this table perhaps a little bit better. Right, so I said we don't work on raw data, so what I'm going to do is going to right click. I'm going to click on move or copy, and I'm going to create a copy. Okay, so that will appear in there now, so I'll move that back to the beginning. So we've got this here. There's a bunch of stuff here which I'm just going to delete, so let's pause the video for a second. Right, okay, so at the moment we've got a table in orders women, then men, and then sort of body weight randomly. There's a number of different ways you could do that. It doesn't make any difference to the statistical test, but we'll just have a quick look at some of the things we could do. I'm just going to copy these data. Right click and copy, and go down here and paste. Wherever it is, paste. Yeah, okay, paste. Right, so again, I haven't messed with the data up here. So one thing we might want to do is sort it out based on increasing weight. So I'm just going to select the whole column there. Again, right click, and then go to sort. Sort largest, sort smallest to largest, seems reasonable. It asks us if we want to expand the selection, and we do, because we want to bring in the column for gender. Click on sort, and now it's organised it based on smallest weight up to largest weight. And it's a mixture of men and women. We'll have a look at what that looks like when we graph it. So, doing a graph, we'll just do a couple of standard graphs first. So we just select these data, go to insert as usual, recommended charts, and as usual, probably the best one is just the clustered column. Drop that in there. I'm not going to add the labels and the axis labels and the chart titles and things like that, because it takes a little bit of time, and you can have a look at this in the data presentation workbook. So again, if you select this one and copy here, I don't want to copy, one to insert, don't we? Insert recommended charts. So again, we'll just have the clustered column, and we can see it's going up as you might expect based on the way we organize the data. Right, now as I mentioned, you should always have axes tiles, graph tiles, and title and numbers for the graphs as well. So if you look at the second page, actually what I should have done was put in a little bit of other data first, a little bit of due diligence. Right, so it's always a good idea in data like this to get the averages and the standard deviations. There are two groups here, so we're going to go average can't spell for some reason. Average men. It's because I'm looking over my microphone is why. And average, stuck in men again, so we'll just edit that to be women. The other thing we could do is we can count up the numbers. There's a number of ways you can do this. We'll have a look at how to do it a slightly fancy way. So we'll just add another row heading, count men. Oops, if we pull down, we'll get the whole thing pulled down, and we can just edit it. Oops. And women. Right, okay, so we calculate the averages in the way we normally calculate the averages. So equals average average for men, so we start from men, so we need to get these numbers in here. Close brackets. Get the average for the men and the average for the women. So again, just making sure we just select the women. Gonna have them in there. Right, so count. There's a function called count, which I think we look at in a later video, but we can use something called Countif as well, which is slightly more sophisticated. So we type equals Countif, and it brings up this little helper to tell us what we need. So we want to put the range in first, which is all of the data. Okay, and then it's criteria. In this case, we're going to do men first. So we put in a quote, and we type in man, because that's what it's got in the column. We close that, and it should tell us that there are no men. Why does it tell us no men? Because I've used the wrong column. Should use this column, obviously. Yeah, okay, I should use this column. So there are 10. I'll just do a F4 on this, just to make sure the data remains the same, and we pull down the same number in it, and it's actually going to be the same number whatever we do, isn't it? Because it's the same number. Woman, yeah, okay. Then we would do our normal sort of formatting on this, maybe put a box around it. I often like to highlight it in green or some other colour just to show it's okay. So there's our sort of basic things. One thing I didn't do in there was standard deviation. Again, if you look in standard deviation, I've included the standard deviations as well, which are obviously useful. But next thing we want to look at is the box and whisker plot. Again, we select all of the data. Make sure we select the whole table, including headings. We go into insert, go into recommended charts, and then we'll have to go to all charts and down there for box and whisker. And it appears here. Right, so again, I'm not going to add the chart headings and things like that. You can have a look at data presentation tab for what we've got here. When you look at box and whisker plots, if you go into there, you'll see, and we move across, you'll see a little dot at the top is said to be an outlier. That's something which is quite a long way from the rest of the data. If you look at these, they aren't particularly symmetrical, are they? So it may be that there's a suggestion this data is not normally distributed. Just looking at this, we need to do more statistical tests on that before we can decide that. Now, as I say, I'm not going to waste time by adding labels and things. They are in this worked example. So we get a title for the table, data for body weights of men and women. In graph 1, we've said it's data for body weight of group of men and women. We've also said n equals 20. That's the sample size, which 10 are women and 10 are men. The second two, it's the same data except it's sorted in increasing order of weight. Then the third graph through, is a box and whisker plot. Again, we've quoted the n values. Right, so on to the statistical tests. So this data presentation we've looked at. We now go to the unpaired test. Now, I've got all the data in here already, and I've also put some images in to summarise the information I've used, and there's our values. Right, okay, so we're on the worksheet for the unpaired T-test. I've already worked everything out and included a couple of images showing the parameters we used, both in terms of the tool we used and what we put into it. Okay, right, let's have a walkthrough of it. Go to data analysis, and we're using a T-test with 2 samples assuming unequal variances. Now, we should already have my information in, but we'll go through it again. We've got 2 ranges, one for men, one for women. So we need to be careful and pick these from the table. They're already selected, but I'll select them again. So we just pick the data for women. We go down here, we just pick the data for men. Okay, our alpha is 0.05. We want to set our output range to somewhere convenient, so we'll just click in there. Click on OK, and the data will appear. Now, as I said, we've already got these data here already. We notice the p-value is 0.0053, which is quite a lot less than alpha, 0.005. So we can reject the null hypothesis and accept the alternative hypothesis that women's average weight is significantly different from men's average weight, at least for this sample group. You might say, well, that's probably going to be true for larger sample groups, but we don't know that until we actually do the experiment. Right, okay, so there's some sample data here for you to play with, looking at rats being fed different diets, one high protein, one low protein, and there's some tasks for you to carry out. Develop a suitable hypothesis, plot some graphs, plot a box and whisker plot to look at symmetry, make sure you add all appropriate labels, etc. to graphs, carry out a paired T-test. In this case, that should be an unpaired T-test, so I will correct that, an unpaired T-test. and consider results and practice copying results, etc. into Word documents. And then over here, don't look at it yet, there is a worked example. Okay, so go back to raw data, and that's